Hello, this video shows how to enter data for a non-Siemens synchronous rotary motor. The steps here assume that a unit configuration has been carried out and that the line module has been configured. Normally, with a Siemens motor, all necessary motor information is automatically input into the drive data. With a non-Siemens motor, this is not the case, and the data must be manually input. It is important to note that the motor data must be provided by the motor manufacturer. In the case of this example, the motor data was provided by the motor manufacturer and had previously been tested on Siemens SINUMERIK S120 drives. To start, we must navigate to the setup area. Select Drive System, Drives, and this is the axis that we need to add the third-party motor to. You'll notice there's a message in the middle of the window here stating that the drive object must be started up. We're going to start by hitting the Change button, and we open a page which allows us to flash the LED on the motor module so we can identify that we are on the correct module, and a location where we can select function modules if necessary. Hit the Next Step soft key. And we need to enter the motor data. We do not want to select a standard Siemens motor, so we select the bullet here and hit the Next Step soft key. You'll notice here that the system has identified the fact that the motor does have a holding brake and has made the appropriate setting. No other settings are necessary for this application. Continue with the Next Step soft key. And this brings us to the first set of motor data that we must input. You'll see that there's a note stating that the motor data must be input completely, which means this motor data is necessary, and again, this motor data must come from the motor manufacturer. So I'll begin entering this data. Once the data has been input, there's the option of inputting the equivalent circuit diagram data or de-checking this. For a synchronous motor, we should always input the equivalent circuit diagram data, which again must come from the motor manufacturer. So we can hit the Next Step soft key. And that brings us to an even longer list of data, which you'll notice is called optional motor data and says it does not need to be input completely. The more of this data you have, the better. But if you do not have complete data, it's okay just to leave these at the default. So I'm going to go offline here for a moment and enter this data, and then I'll come back. Now that this data has been entered, we can hit the Next Step button to proceed to the final screen of motor data. This data, known as the replacement circuit diagram data, must be input. And once again, I do not have the complete data, so I'll just input the data that I do have. Once I'm finished, I'll hit the Next Step button, and you'll see that the system asks if it's okay to calculate the closed loop controller data. We want to say yes. And we see here that the system has automatically identified the correct sensor module because it is connected to the correct drive click port on the drive so we can hit the next step soft key. Since this is a non-Siemens motor, the system does not know what type of encoder is in the motor, so we have to use the enter data soft key to enter the encoder data. It is a rotary encoder, incremental sine cosine, 2048 pulses per revolution with 1 0 mark per revolution. We do want to use pole position identification, and we also want to use fine synchronization with 0 marks. It's important to note that I am not inverting the speed actual or position actual value. That's important from the standpoint that with a motor of this type, the clockwise phase rotation of the motor has to equal positive encoder feedback. If it didn't, then I would have to invert the actual values. So this is one step that is not being shown in this example, but it is an important step that has to be checked at some point with every motor. But this motor, fortunately, has known values, and therefore I am not having to check. We want to go into the pole position identification parameters. This particular motor, the manufacturer has stated that it works best with saturation-based two-stage. And we have data that we entered previously for that. So we can select the OK soft key. Now we have entered our encoder data, and you'll see that it's highlighted that it is a user-defined encoder. Next step, standard telegram information and drive dataset number, all okay for this application. And we do want to use standard terminal wiring. Next step, here we have the option of saving the configuration information as a text file. If we don't need to do that, we can just select the finished soft key. And then we must acknowledge this dialog window asking if we want to save the information in a non-volatile manner. Once that's done, you'll notice that there's a message stating that the angular commutation offset determination is active for this axis, and that simply means that on the first enable of this axis, the system is going to identify a commutation angle offset. This is something covered in more detail in another video, so it will not be addressed in detail here. Before you can perform the commutation offset determination, the newly configured drive must be assigned to an axis. That can be done using the axis assignment button here. Select the axis it belongs to, in this case the x-axis, and then select the OK soft key, and then allow it to do an NCK reset. After the system comes back from the NCK reset, the notification that the commutation determination is going to be performed will have gone away. And you can go into the drive parameters and turn that back on here in parameter 1990, simply by setting it to a 1, and that will be ready to run again. So that concludes the video on how to enter data for third-party motors. Thank you very much.